In this video, we will discuss working of LVDT for displacement measurement. So, my name is Amol and I am lecturer in Electrical Engineering Department from K.K.Wagh Polytechnic Nashik. So, before start our lecture, let's see the content of this lecture. So, first we will briefly discuss what is transducer, then construction of LVDT, working principle of LVDT, and then we will discuss in detail working of LVDT for displacement measurement. So first, let's see what is transducer. A transducer is an electronic device which converts energy from one form to another, and some examples surrounding us are microphones and loudspeakers, which converts electrical signal into sound energy and also sound energy into electrical signals. So these principles or concept used to measure various physical quantities in terms of electrical signals. So LVDT is also one type of electromechanical transducer. LVDT means Linear Variable Differential Transducer, which converts physical displacement into electrical voltage. Now let's see its construction. LVDT consists of one primary winding P and two secondary windings S1 and S2 mounted on a cylindrical former as shown in this figure, and both secondary windings, that is S1 and S2, has an equal number of turns and placed identically on either sides of primary windings in such a way that the net output will be the difference of voltage induced in both secondary windings, that is V out is equal to V1 minus V2. Also, there is a movable soft iron core placed as shown in here in this figure. The movable core is laminated to reduce eddy current losses, and the displacement to be measured is attached to this movable core. Now let's see working principle of LVDT. The working principle of LVDT is based on mutual induction principle, that is, when AC excitation is applied to the primary winding, then a magnetic field is produced around it. Due to this magnetic field, EMF is induced in both secondary windings. Let's EMF V1 and V2 are induced in secondary winding S1 and S2 respectively. Now, as both secondary windings are connected in series opposition, so net output voltage will be the difference between both induced voltage in secondary windings. Hence, the differential output of LVDT will be V out is equal to V1 minus V2. Now, let's see how LVDT is used to measure displacement. According to the position of core, there are three cases that arises. So let's discuss one by one. The case 1 is when core is at null position, and when core is at null position, then the flux linkages with both secondary windings will be ideally same. So induced EMF V1 and V2 are also same, that is V1 is equal to V2. Hence the net differential output V out is equal to V1 minus V2 will be 0. That means there is no displacement in core. Therefore, for zero displacement, output of LVDT is also 0. Now let's consider second case, when core moves towards S1 and when the core of LVDT moves towards secondary winding S1, which is in left side in this figure, then in this case the flux linkages with S1 will be more as compared to S2. This means that EMF induced in S1 will be more than EMF induced in S2. Hence net differential output V out V1 minus V2 will be positive, and depending upon its value the displacement can be measured in left side. That is, as displacement increases, output also increases in positive side. Now third case, when core moves towards S2 and when the core of LVDT moves towards secondary winding S2, which is in right side in the figure, then In this case, the flux linkages with S2 will be more as compared to S1. That means EMF induced in secondary winding S2 is more than EMF induced in S1. Hence, net differential output, that is Vout is equal to V1 minus V2 is negative, and depending upon displacement in right side, the negative voltage increases or varies. So in this way, LVDT used to measure displacement. Now let's take quick overview with key points. That is, output will be 0 for null displacement. The direction of movement or displacement can be identified by sign of output voltage. That is, for left side movement voltage is positive, and for right side movement voltage is negative. So in this way, LVDT is used to measure linear displacement. So I hope you understand the working of LVDT for measurement of linear displacement. And if you have any feedback or suggestions, please email on my email ID. Thanks for watching.